Solving ODEs using Laplace transform. The Laplace transform is technique for transforming a time domain function ft into a function in the complex domain fs. So remember, Laplace transform is a technique to transform from a time domain ft into the complex domain fs. Why use Laplace transform? It can be used to simplify and solve linear ordinary differential equation by converting the differential equation into algebraic equation. Laplace transform handles initial condition easily. Laplace transform of derivatives. Let ft be a function of t. Therefore, f prime t and f double prime t are the first and the second derivative of ft. The Laplace transform of ft is fs, which is written here. Laplace of ft is fs. Now the formula begins here. The Laplace of f prime t. The Laplace of the first derivative equal to sfs minus f0. The Laplace of second derivative equal to s square fs minus sf0 minus f prime 0. For general case where the derivative is to end, so we have this formula. This formula can be found in mathematical formula book on page 54. So make sure you know the position of that formula. Please refer to mathematical formula page 54, section 7.8, number 2, 3, and 4. Right? Steps for solving ODEs. The first step is to take the Laplace transform on both sides of the ODE, then convert the ODE into an algebraic equation in terms of S, means that we will find the Laplace domain. Then solve for capital F, which is the Laplace transform of the unknown function. Lastly, apply inverse Laplace transform to find the solution ft in the time domain. Okay, now let's do this example. Solve the following first order ODE using the Laplace transform. The ODE is y prime t plus yt equal to e minus 2t, comma y0, 0. y0 equal to 0 is the initial condition, and the ODE itself is this equation. So the first step, since the requirement is to use Laplace transform, so you have to apply Laplace on both sides of the differential equation. So it becomes Laplace of yt plus yt equal to Laplace of e minus 2t. Then, on the left hand side, by using the linearity property, we can separate this and it becomes Laplace of y prime t plus Laplace of yt equal to the right hand side element. It remains the same. Now look at each term. You have to find the Laplace of the first derivative. So we will use the previous formula here to solve this. So the formula that we want to find is the first derivative, which is the Laplace of f prime equal to sfs minus f0. Since our equation here involves y, to adapt this behavior, we must convert the formula from f to y. So f become y and capital F becomes capital Y. Right? So we will copy the formula. The Laplace of the first derivative is s ys minus y0. So that is the expansion for this single term. You get two terms. Next, the Laplace of y is just capital Y, like this. And the Laplace of e negative 2t can be found by using table. Okay, look at the row where we have e negative at. The transformation is as 1 over s plus a. Now this case a equal to 2, so the Laplace is e negative 2t. It becomes 1 over s plus 2. So that is your terms on the right hand side. Now we want to simplify. Okay, look here, we have s, ys, and y0. Notice that y0 is given, right, as the initial condition. Y0 is 0, so means that you can substitute this into 0. Next, to solve this, you can factor ys with ys, right? So let's write it, the factor of ys, and the term is s plus 1, right? That is on the left hand side. On the right remain what it is. So we want ys as the function. So now the right hand side become this one. So this is your Laplace in frequency domain. You need to find yt, not capital Ys. So the next step is to solve this. Means that since ys in the form of fraction, you can apply partial fraction to that. So the partial fraction of 1 over s plus 2, s plus 1 equal to, since this is, we have two factors, right? So the partial fraction is a over s plus 2 plus b over s plus 1. Okay. So next we want to solve a and b. So look at the first term. To get the original fraction, you should multiply by s plus 1 on the upper and lower part. For the second term, you have to multiply by s plus 2, right? So now your equation can be written by a s plus 1 plus b s plus 2 equal to 1, okay, equal to this value. Now we want to expand this, so as plus a plus bs plus 2b equal to 1. Now let's collect the similar terms which has the same variable. So you have a plus b s and then plus a plus 2b as the remaining term equal to 1. On the left you have s, but on the right you don't have s, means that it is actually plus 0s. So now you can write a plus b equal to 0 because no element of s here. And then a plus 2b, the remaining term here, equal to the number, so it is equal to 1. So this is the system of equation where you have two equations with two unknowns. Solve this by using simultaneous equation, and you can use your calculator, and then your result can be found like this: a equal to minus 1 and b equal to 1. Okay. After that, you can rewrite your partial fraction 1 over s plus 2 over s plus 1 equal to a. Replace a, so it becomes negative, right? Negative 1 s plus 2, and replace b here is 1 s plus 1. So this is the fraction. From the complex fraction that we can solve, you have to decompose by using partial fraction to get a simpler version, so that from here we can find the Laplace, the inverse Laplace. Okay, the next step, you want to find yt, right? Yt is the Laplace inverse of ys. Okay, so what we have here, your capital YS can be written by this term, negative. I put negative in front, okay, and then Laplace inverse of 1 over s plus 1. So we can solve this by referring to the table of Laplace transform 1 over s plus 2. We must refer to this e power negative 80. The Laplace transform is s plus e. Now your e is 2, so the first term is e negative 2t plus. This one, 1 over s plus 1, can be can be solved by using the same row of from the table of Laplace transform. Now your a is 1, so the answer e negative t. So now you obtain your result yt as the solution, which is e negative 2t plus e negative t.